In this video, we are going to explore the site-specific scenario generator. We need to choose a study site. Global is the default, but we will be working with data from Zambia. By double-clicking on Zambia, it will open as our study area, and we will then return to the icon for the site-specific scenario generator, and a new dialog box will open along with a map of Zambia. We will resize the map and move the scenario dialog box over against it. Like with the spatial scenario generator, you have the same options within the site-specific. For example, precipitation and the other variables available within the data you have loaded. You have access to the GCM patterns, so you can work with an individual GCM pattern or an ensemble. We will return to that in a moment. Also, there are choices of emission scenarios known as the SRES. Like with the spatial scenario generator, you get to choose all of the months for application for the whole year, or you can choose various months to represent seasons. You also have an area in the dialog box for displaying of the data, and the icon for producing a graph. We can also look at a percentage calculation, which we won't do in this video, but you can have a look at that when you are using the tool. Most importantly is perhaps the normalized GCM values icon. We will explore its outputs in this video. As it is a site-specific scenario generator, we need to choose a site. We can either type in the longitude and latitude of a site that we are interested in, or we can go over to the map and click on a particular site and its longitude and latitude, and a normalized GCM value will load automatically. We can look in an ensemble for this area, so we will open the ensemble options. We have already created one for Zambia. There is another video in this series that details how to create ensembles. While the data is loading, we will quickly discuss the options available for graphing within this dialog box. When the data is loaded, we can export that data to Excel or to our clipboard and use it in other programs loaded on our computer, and we can graph and export those graphs as well. It takes a little while to load all the GCM data for this particular part of Zambia, but because it is ensemble, it is cached, so in future applications of the tool, it will load that data more quickly when you do a second or third analysis. The data is now loaded. We know where we are going to look in this longitude and latitude, and we proceed to load the data and the values for the A1B scenario. And those data appear. We can click on the graphing icon to generate a graph for that site. We can then explore the effect of different emission scenarios and load that data and produce a graph. You can see different curves created with different values. The A1FI high sensitivity output depicts a slight drying trend for this particular area. You can save these graphs and import them into a PowerPoint or other presentation, and you can also apply different SRES emission scenarios. SimCLIM quickly computes a range of possibilities for this particular site and different SRES using an ensemble. We will close these and have a look at what happens when we click on the normalized GCEM values icon. A third dialog box opens and it has retrieved the GCM data for this particular site in Zambia. When it is loaded, it will present data for each month and an annual total. We will expand this dialog box slightly so we can see all the GCM patterns available in a list and how that GCM performs on a monthly basis for this particular site. You can see there is variability across the GCM outputs. This is what we call the signal for each GCM. If we click on the top of the column, it will order those, so you can now see the lowest is minus 4.09. This number represents the percentage change per degree of global warming. The negative number means that this GCM for this month shows a drying trend for the site. There are also positive numbers that represent wetting, and at the bottom of the table we can see an increase of 2.44% per degree of global warming. When we talk about the signal, you can see that there is not a very strong signal in this particular site in Zambia. There are an almost equal number of patterns showing a drying as wetting. Yet, there is a slightly stronger trend toward drying within those that are showing drying, and this is reflected in the median value at the bottom, where summary statistics are to be found. But as you can see, there can be variability across months as well in terms of the signal coming through the GCM patterns. We can also look at the high and the low percentile, which can be changed quite easily by changing these numbers. The program is very responsive in terms of outputs for percentiles and looking at the range of uncertainty for a particular site. This is a very important tool for exploring GCMs. As we mentioned, the range of uncertainty in GCM patterns is important to understand in any project you do. We suggest the use of this tool for exploring the signal across the GCM patterns and the strength of that signal. It's also quite instructive as well in exploring how GCMs are performing across individual months.